Hello and welcome to Mathematical Coaching Center. Today in this video, we'll be solving few problems related to angles in a circle. And this is the third part of the video. And if you have not seen the first two parts, the link will be given in the description. But before we start, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further ado, let's start with the video. In this video, we'll be using two theorems to solve our problem. So the first theorem that we will be using is the opposite angles of a cyclic quadrilateral are supplementary. So we have a term cyclic quadrilateral here. Okay, so what is a cyclic quadrilateral? Quadrilateral are a figure having four sides, or a figure bounded by four sides, and a cyclic quadrilateral means the vertices of that quadrilateral should lie in a circle. So let's understand this with the help of a diagram. So if there's a circle with center O, and if we choose 4 points on a circle and draw a quadrilateral, so this kind of quadrilateral is known as a cyclic quadrilateral. Okay, now it says that the opposite angle of cyclic quadrilateral are supplementary. So the opposite angle, that is the angle ABC, that is this angle here and this angle here, these two angles will be supplementary, which means that the sum of these two angles should be equal to 180 degree or two right angles. But not only this angle, but the other two angles, that is the angle BCD and BAD, will also be supplementary, and the sum will be equal to 180 degree or two right angles. Okay, we have angle ABC plus ACD, that is this angle here, will be equal to two right angle. The sum will be equal to two right angle. And BCD, that is this angle, and BAD, that is this angle here, will again be two right angles. So this is what the statement of this theorem says. Let's see the next theorem that we will be using. So the next theorem that we will be using states that the exterior angle of cyclic quadrilateral is equal to the opposite interior angle. Again, we have cyclic quadrilateral and we need to make an exterior angle. Okay, so suppose there is a circle with center O, and there is 4 points in that circle, and we draw a quadrilateral with the help of that 4 points. So to get an exterior angle, what we will do is we'll extend one of the sides of that quadrilateral. So let's extend the side AB. So we have extended the side AB to the point till E. Okay, now the angle that is formed here is known as the exterior angle. So the exterior angle will be equal to the interior opposite angle. So we have four interior angles here. So this is 1, this is 2, this is 3, and this is 4. But this exterior angle will be equal to opposite interior angle. See, so this is opposite interior angle. So we have these two angles are equal. So that is what the statement of this theorem says. Okay, that is angle CBE will be equals to angle ADC. So we'll be using these two theorems to solve our problem. So let's start with the first problem. So in the given figure, if angle BCD is equals to 130 degree and AD is the diameter of a circle, so calculate angle DAB and ADB. So as always, we'll start by writing what is given. So it's given that angle BCD is 130 degree. So let us see where this 130 degree lies in the diagram. So this is angle BCD. So this is angle BCD. So the measurement of this angle is 130 degree. Now we need to calculate angle DAB. So DAB is this angle here, DAB is this angle here, and ADB, and ADB is this angle here, the small angle here. Okay, not the whole angle, but the small part of the angle. Now what we will do is, now the figure ABCD, you can see that it has four sides and this is a quadrilateral. Okay, and what kind of quadrilateral is that? And this is a cyclic quadrilateral. And you can see that this angle and this angle are the opposite angles there. You see that these two angles are opposite angles. So angle DAB plus angle BCD will be equal to 180 degree, since the sum of the opposite angles of cyclic quadrilateral is 180 degree or 2 right angle. Okay, since it is 180 degree, we get angle DAB plus BCD is given as 130 degree, that will be equal to 180 degree. Taking this 130 onto this side, we have angle DAB is 180 minus 130 and angle DAB will be equal to 50 degree. So we have angle DAB as 50 degree. Now what we need the measurement of this small angle here. Now to find this angle, what we will do is we'll take the help of the angle that is here. Okay, now since AD is the diameter of a circle, therefore we have angle ABD is 90 degree. This angle here is 90 degree. And why is that so? Because this is the angle in the semicircle. Now you can see that AD is the diameter and this angle here is the angle standing on the diameter AD. That means this will be the angle at the semicircle, so it will always be 90 degree, since the angle in the semicircle is 90 degree. Now in triangle ABD, that is this triangle here, we have angle ADB plus angle ABD plus angle DAB is 180 degree, because the sum of all the angles of a triangle will be equal to 180 degree. Okay, this angle here, this angle here, and this angle here, small angle here, when added should give us 180 degree. Okay, now we have the measurement of angle ABD is 90 and DAB we have taken out to be 50. Putting those values, we have angle ADB plus 90 plus 50 equals 180 degree. So adding 90 plus 50, we have angle ADB plus 140 degree is equals to 180 degree. Taking 140 onto this side, on the right hand side we have ADB is equals to 180 minus 140. So we'll have angle ADB is equals to 40 degree. So the measurement of angle DAB is 50 degree and ADB is 40 degree. So this is how we solve this problem. Now let's see one more example. So in the next question it is given that in a given figure, if angle ACE is 43 degree and angle CAF is 62 degree, find the value of A, B and C. We need to find the value of A, B and C, that is this angle here, this angle here is B and this angle here is C. We need to find the value of these three angles. Okay, so as always we'll start by writing what is given. So given angle ACE is 43 degree, so in the diagram this is angle ACE, so this is 43 degree, and the next is given as angle CAF, that is 62 degree, and in the diagram it's this is angle CAF, this is angle CF, and that is 62 degree. Now I can see that there's a quadrilateral here, ABDE. See, it's a quadrilateral, and what kind of quadrilateral is that? It is a cyclic quadrilateral. Okay, so now we'll be using this cyclic quadrilateral. Now let's take the cyclic quadrilateral out of the diagram so that it becomes easier for us to understand. See, this is a cyclic quadrilateral and this is an external angle here. Can you see that? This is the external angle and this is the opposite interior angle. Okay, can you see that? This angle here is the interior and this angle here is the opposite exterior angle. So if you are not able to see that, let's rotate this figure. So if you rotate this, now you can see that this is a quadrilateral here. So this is an external angle and this is the opposite interior angle. So this angle here will be equal to this angle here. So that is angle B will be equal to angle CAF. Okay, this will be equal to angle CF, that is this angle here. These two angles will be equal. And why are these two angles equal? Because in a cyclic quadrilateral, exterior angle is equal to opposite interior angle. So what will be the measurement of B? So the measurement of B will be equal to 62 degree. So we got the value of B as 62 degree. Okay, now let's solve for A and C. Now what we'll do is BDC. Okay, so this is angle BDC here. BDC and angle B will equal, see, and BDC is this angle here, and this is angle B. Okay, this will be equal. Why? Because these are vertically opposite angle. So this is a vertically opposite angle. So these two angles will be equal. So angle BDC will be 62 degrees. So this is 62 degree. So this is also 62 degree. Now there's a triangle here. BCD is a triangle here. Can you see that? So this is a triangle, and the angle A is the exterior angle to this triangle. Okay, this A is an exterior angle to this triangle here. Now therefore in a triangle BCD, angle A will be equal to angle BCD, that is this angle here, and BDC, that is, okay, BCD is this angle here and BDC is this angle here. This the sum of these two angles will give us A. Why? Because in a triangle, exterior angle will be equal to sum of the opposite interior angle. So angle A will be 43 plus 62 degree. So angle A after adding will get as 105 degree. So this is 105 degree here. Now let's solve for C. Now we know that ABD is a cyclic quadrilateral. Okay, because the vertices of this quadrilateral lies in a circle, and this angle here is an external angle. Can you see that? DEF is an external angle here. Okay, so this is an external angle here, and this angle will be equal to opposite interior angle. So this is the opposite interior angle. Okay, so this will be equal to angle A. Now since in the cyclic quadrilateral, external angle is equal to opposite interior angle, so what is the measurement of angle A? Angle A, we got it to be 105. So angle DEF will also be 105. Now in this triangle here, in this small triangle DEF, all the measurement of two angles are known. We need to find the measurement of the third angle, that is angle C. So angle C plus angle DEF plus angle EDF will be equal to 180 degree. Why? Because sum of the angles in a triangle is 180 degree. Okay, so for this reason we get the sum to be 180 degree. Now putting the values of DEF and EDF, we have 105 plus 62 is equals to 180 degree. So adding this to 105 plus 62 will give 167, and taking 167 onto this side, we get angle C to be 180 minus 167, and angle C is equals to 13 degree. So this is the measurement of angle C. So what are the values of A, B and C? The values of A, B and C are A is 105, B is 62 and C is 13 degree. So this is how we solve this kind of problem. I hope that this video was helpful for you in understanding how to solve this kind of problems. If you like this video, give it a thumbs up, and if you're new to this channel, subscribe to the channel and turn on the notification bell. Thank you for watching and have a very good day.